Good day, everyone. This is Chris with the Ancient Scholar. We're going to continue talking about the immune system and specifically immunity today, how we develop immunity. So let's just go ahead and break this down real quick. There are essentially two types of immunity. There's something called native immunity and acquired immunity. Now, when we look at native immunity is the primary response. It's the body's primary response to exposure to something called an antigen, and we'll talk about antigens here in just a little bit. Other terms you may hear for the term native immunity is natural immunity, humoral, non-specific immunity, and basically what native immunity is, it's this first response that the body does when it comes into contact with something it identifies as bad or pathogenic or disease-causing. And that's generally going to include the inflammatory response. The inflammatory response is often the body's primary, or the first mechanism by which it protects itself. That's why when you have an allergy attack, for example, you get a stuffy nose, it runs, you get a lot of mucus created, and that part of the inflammatory process is a way of protecting. We make more mucus, we get rid of stuff. Some people even have diarrhea, and it's just simply a mechanism to prevent this antigenic material from getting into the body, and the inflammatory process plays a really big role in that. And also the inflammatory process increases the permeability of blood vessels and can make them more leaky, if you want to look at it that way, and that allows immune cells to leave the blood vessels and get out into the tissues and into the mucosal layers and so on. Okay, there's also something called acquired immunity. This is also known as adaptive or specific or even induced immunity. And this type of immunity is specific. It's not like inflammation, where inflammation is pretty non-specific to if there's something pathogenic or an antigen, I'm going to have this massive inflammatory response. The acquired immunity works a little differently in that the acquired immunity is very specific to certain types of antigens. So let's say that you are exposed to a virus that you've never been exposed to before. Well, your native immunity will kick in. You will have an inflammatory response, but it takes the body a while to make antibodies for that specific virus that attacked us. However, let's say next year rolls along now. I already have these antibodies for this specific virus, and let's say that I get this virus again. Well, the body remembers that, and there are already antibodies produced for that specific virus, and you don't get sick because of that. And that is the basis behind acquired immunity. It's something that takes a little time to work. You have to be exposed to something first, to an antigen first, and then it takes some time for it to make antibodies and so on. A subgroup of acquired immunity is something known as passive immunity. And a good example of this is certain antibodies can be transferred from mom to baby. And often, because babies are really born, infants are pretty much born without an immune system, without a developed immune system. So they do rely somewhat on the antibodies from mom. Certain types of antibodies, not all of them, can cross the placental barrier, but certain types can, to help protect the baby somewhat while the baby is developing in the first weeks of its life. Another example of acquired immunity is something we see a lot, and that's through immunizations. I get immunized for a certain disease, and I basically have a weakened or a dead virus, and even a bacteria. I think on the last video I said that generally this antigen antibody response is a viral thing, and it's definitely associated with viruses, but make no mistake, we still make antibodies for bacteria or for antigenic parts of bacteria. So certainly this can occur with bacteria as well as any kind of complex substance that has proteins and so on and so forth in it. So immunization is also a form of acquired immunity where I give the body something, usually a weakened or an attenuated virus, or even a bacteria like the meningococcal vaccine vaccinates against a certain type of bacteria that can cause meningitis. And so we do even have vaccines for bacteria as well, not only viruses, although we do have a lot of vaccines for viruses. And the same thing occurs. The body recognizes that material as antigenic. You know, sometimes it's just a little part of a viral capsule wall, and that's all that's needed to make this immune response. And then we have antibodies, and if we ever get exposed to that virus in the future, we already have those antibodies built, and they can take care of that, hopefully, before we get sick. Okay, so before I leave you guys, it's kind of a short video, but this will lead into talking about some little more advanced concepts. But so basically what happens, when we're exposed to an antigen, our body creates antibodies, and antibodies bind to antigens. They're very specific. Certain types of antibodies will bind to antigens, and basically that binding can cause lots of things to occur. It can cause antigens to kind of clump together, and when they clump together, of course, that makes it easier for other white blood cells to come in and take care of whatever's making that antigen. You know, hopefully it's a virus or bacteria, and the body can come in and get rid of it. It also is kind of like a beacon. It attaches to an antigen, and it's kind of like a little beacon, and it through chemical messaging can tell other immune cells, hey, we've got something here, take care of it. So that's generally how that's the basic principle behind the immune response. Okay, guys, take care. Thanks for hanging in there.